All right, welcome everybody. Let's do this. So what I'd like you to do is first take a second and have this down in your notes. Copy it down, right? So let's say you have it. Let's examine the point 3, comma 4 in the coordinate plane. So where would 3, comma 4 be? And remember that we always have our x goes first, and then the next is our y. So remember, this is our x-axis, this is our y-axis. So here we're going to go positive 3 first. So where is positive 3? It would be, 1, 2, 3. Okay, so this is our x equals 3 here, and we have y equals 4. So we're just going to go up 4, 1, 2, 3, 4. And this is our point. This is the point 3, comma 4. Now, for a quick question, let's imagine we make a triangle, right? So what we're going to do is we're going to make one side of the triangle like this. Another side of the triangle will be on the x-axis, right here. And then the hypotenuse for the triangle will be just like this. Okay. So, and let's label the triangle as well. Let's say we have, let's see. Okay, this is a great camera angle. Let's say we have A, B, and C. So we have A, B, and C. Let's answer the first question. What is the length of A to B? So what would this length be from here to here? And okay, so this shouldn't be too bad. It's just 3. Notice, right? You just go 1, 2, 3, and this is the length of A to B. And notice that the length of A to B matches the x value. So whatever this x value is, this is going to be the horizontal distance A to B. What's the next question? What's the length of B to C? Well, B to C is just simply 1, 2, 3, 4, but B to C also matches what the y value is, which is 4. So this is 4 over here. So let's answer this question here. It's saying, what's the length of A to C? Now this, we need to do a little bit of math to figure this out. We know that if we have this triangle, and if we draw it here, that if this is 3, this is 4, what will this be over here? Well, there's a very famous formula we could use. It's called the Pythagorean Theorem that says if a squared plus b squared equals c squared, if we have a right triangle. And notice this is the type of triangle we have. We have a right triangle, so we're allowed to do that here. And notice that this c represents the hypotenuse, and the a and the b are the legs of the triangle. Okay? So now let's actually solve for the length of A to C. How do we do it? Notice that if we have any right triangle, and I'll just have it like this, if this is your A, this is your B, and this is your C, what would our A be over here? Our A is 3. So we have 3 squared plus what is our B over here? It's going to be 4 squared equals C squared. Okay? So then let's just do this. 3 squared is 9. Plus 4 squared is 16 equals c squared. And then 9 plus 16 is 25 equals c squared. And then once you get to this point that 25 equals c squared, how do you continue forward to get c by itself? We're going to take the square root. We're going to take the square root of both sides. And notice what square root of 25? It's 5. And the square root of c is, the square root of c squared is just c. And this c represents the hypotenuse of the triangle, or the length of A to C, which is 5 over here. Okie dokie? Okie dokie. So just a little summary, just so we're okay with this. Let's imagine if I had, let's say if we have a point, I don't know, let's say it's xy. Whatever that point xy is, it could be anything. If I said, hey, what's the distance from here to here? Like, what's this distance here? It'll have to match x. Okay? The same reason, like if I said, what's the distance from here to here? And match that x, or that 3. Okay? What if we asked, what's the distance from here to here? This would match the y. Okay? The same reason, the same way we did it here with the 4. Okay? So let's try and look at the next question. Revolving around trig. So here, Now, take a second and copy this down. And it looks a little scary when you first look at it, but it's really not too bad. It's saying, let's examine the point P, negative square root of 7 over 4, comma, y, which lies on the unit circle. So let's just get a quick reminder. What is the unit circle that we've been talking about? Remember that the unit circle has the equation x squared plus y squared equals 1. And what do you know about the unit circle? That the radius of the circle is 1. So if I take a point from here to any point on the circle, like what's the distance from here to here? 1. What's the distance from here to here? 1. What's the distance? It doesn't matter where you go on the circle, the radius of the circle is always 1. Okay? Now, what is this question saying? It's saying you know the point. So if we have a point, it's x comma y. You know that the x value for this point is negative square root of 7 over 4. Now the question is, what is the y value? And how would we actually do this? So the little trick to actually begin this process is, let's create a triangle. Just kind of like what we did before. Okay? Now, this is the triangle we created. Now, do you know the distance from here to here? Do we know this distance? And based on from what we just did previously before, yes, we do. Because here, whatever the x value is, that represents the distance from here to here. And notice, what is this x value that we have? It's a square root of 7 over 4. And remember, distance is positive, okay? So we know that the distance from here to here is square root of 7 over 4. Do we know the distance from here to here? Which represents the y value. We don't know this distance at all. So this is what we're trying to find. And do we actually know what this distance is over here, from here to here? And yes, we do. The distance from here to here has to be 1 because we're on the unit circle. Remember, anywhere on the unit circle, the distance from the center to any point on the circle will be 1. So notice that we're creating a triangle, and what do we know about the dimensions of this triangle? Well, we just have this. This has to be square root of 7 over 4. This is 1. And what is this? This is some y, right? This is your y here. But now the question is, how do we actually find the value of this? So what we're going to do is we're just going to use the Pythagorean Theorem. We're going to use that a squared plus b squared equals c squared. And notice that if we have this triangle over here, that the hypotenuse is always c. And it doesn't matter where a and b are. A could be here or a could be here. It really doesn't matter. Let's just say this is a and this is b. So notice that what we want to do is we want to somehow solve for this distance here. So here, what is your a value? It is square root of 7 over 4. And what are we going to do with it? We're going to square it. Plus, what is this b value of the triangle? It's y. So we're going to say it's y squared. And what is the c value, the distance from here to here? It's 1. And then this will be the setup to actually find this value over here. So how do we actually do this? How do we actually isolate y in this given equation? Notice that, can we square this? Let's try and do this one first. What is, let me zoom out a little bit, my bad. What is square root of 7 over 4, the whole thing squared? So notice, what do we have to do? Let's break this down simply. We have to do this twice. So it's square root of 7 over 4 times square root of 7 over 4. Right? We're doing 2 of these. So then how do we actually continue? What is square root of 7 times square root of 7? Let's do the top first, right? This should just be square root of 49. And what's on the bottom? What is 4 times 4? It's 16. But what is the square root of 49? What number times itself gives you 49? It's 7. So notice it just becomes 7 over 16 when you actually simplify this out. So this is 7 over 16. Plus, now y squared is just y squared. Oh, I'm sorry. And this should be a 1 squared, right? What is 1 squared? It's just 1. Now, how do you actually continue? If you feel like you could get this by yourself, try and continue. How would you get this y squared by itself? The idea is the first move should be, let's subtract 7 over 16 on both sides, because we want to isolate this y squared. So notice that what is 7 over 16 minus 7 over 16? This cancels. Now we have y squared is equal to, well, now we have to subtract it. What is 1 minus 7 over 16? How do you, now if some of you are like, oh mister, we have to do fractions, it's not too bad. Because notice that what is 1 equal to? 1 is equal to 16 over 16. And why did we say that? I mean, like 1 is equal to a lot of things. I could say 5 over 5. I could say 1 is equal to 1,000 over 1,000. But what's the reason for using 16 over 16? Because there's a 16 in this denominator. When we make this 1 equal to 16 over 16, notice that how do you subtract fractions? The denominators have to be the same. Now that the denominators are the same, what is 16 minus 7? It's just 16 minus 7 is 9 over 16. Okay? And that's why we wanted to change this 1 into 16 over 16 so we could actually subtract these fractions. But just to get to the point, now once we get to this point of y squared equals 9 over 16, how do we actually continue? All we need to do is take the square root of both sides, and now we have y is equal to plus or minus. Now what's here, notice that what's the square root of 9 over 16? It's the same as the square root of 9 over the square root of 16. But what's the square root of 9? Take your time, like try and figure out what's the square root of 9. It's 3. What's the square root of 16? It's 4. So notice that y is equal to plus or minus 3 over 4. Okay? Now, how do you actually continue with this? Now that you know y is equal to plus or minus 3 over 4, let's take a look over here. So once we get to this point, we know y is equal to plus or minus 3 over 4. Now the question is, notice, where is y? Where is y? Y is in quadrant 2, right? Because y is in quadrant 2, what do you know about your values of y? Are your values of y positive or are they negative? You know that in quadrant 2, your y values are positive. So here, y is equal to positive 3 over 4. And that's it. And that's how we got this solution over here. Let's try one more. When I realized this video took 13 minutes, once if you felt okay with this one, the other ones should be okay. But let's try and do one more together. Let's imagine if we have this point, same idea, same question, and what I want you to do is pause the video and try and copy it down, right? Let's say the point P is here in the third quadrant, and it lies on the unit circle. What is the value of x in simplest form? So what I want you to do is try and rewind, and the same kind of method we used to find this triangle, how we found y over here, try and do it for this one here. Right? Let's do this one together. So first, let's make a triangle. Okay. Now, if we have this triangle over here, what do you know about the distance from here to here? Do we actually know this distance? We don't, because this is the x value. The x value, and I'll just write it over here, the x value shows you the horizontal, and the y value shows you the vertical. So what is the horizontal value of this? We don't know. But do we know the vertical value over here? We do. It's square root of 3 over 2. Okay? And what do we know about the distance from here to here? We're on the unit circle, so this distance of the hypotenuse has to be 1. Now, how do you actually find the value of x? Same idea we used before. If we have some sort of triangle, a right triangle over here, this is your A, this is your B, this is your C, and if we have the Pythagorean theorem, a squared plus b squared equals c squared, all we need to do is just substitute these values in. So notice, what is our A value? Our A value is x. So we have x squared plus square root of 3 over 2, the whole thing squared, equals 1 squared. Now, try and solve this on your own. How would you continue? This is x squared. And what does this become? What is square root of 3 over 2, the whole thing squared? Well, this becomes square root of 3 over 2 times square root of 3 over 2, which is equal to square root of 9 over 4, which is equal to 3 over 4. Okay? Take your time and see how I broke this one down, right? So now this becomes 3 over 4 equals 1. So now, how do you actually get x squared by itself? Let's subtract 3 over 4 on both sides. And now we have, let's see, we have x squared is equal to 1 minus 3 over 4 is 1 over 4. Okay? And I'm sorry, why is I forgot. Put 1 minus 3 over 4, right? And how do we actually do 1 minus 3 over 4? We're going to say that 1 is equal to 4 over 4. So we have 4 over 4 minus 3 over 4 is equal to 1 over 4, right? So now you have x squared is equal to 1 over 4. Now how do you actually continue? We're going to take the square root, square root. Now we have x is equal to, notice what's the square root of 1 over 4? It's the square root of 1 over the square root of 4. You're going to take the square root for the numerator and the denominator. What's the square root of 1? It's 1. What's the square root of 4? It's 2. So notice that x is equal to plus or minus 1 over 2. So you know that our x is equal to plus or minus 1 over 2, and you have to ask yourself, your x value, which quadrant is it in? Which quadrant? You're in quadrant 3. What do you know about your x values in quadrant 3? They're negative because they're on the left side of the y-axis, right? The left side over here, all your x values are negative. So you know that your x is equal to negative a half. And that's the point here. You see this point over here is negative a half, negative radical 3 over 2. Okay. What I'd like you to do is, there's a delta math for today, and it goes over these questions. What I'd like you to do is try and do the delta math for today. I'll see you.